Here is an interesting question on equivalent rational functions. The question is, explain if x plus 1 times x minus 1 divided by x minus 1 equals to x plus 1 is true or not. So normally when we are trying to solve a rational function, we do cancel out the common factors and we come up with the result like this is equal to this. Now the question is it true or not? That is the question. Well, the answer is that it is not true. So it is not true. That is the answer. It is not true or not equivalent. So we can say these expressions are not equivalent. The better word is equivalent. Now why they are not equal? This is what we need to understand now, correct? Now if you analyze the two functions, let me rewrite them. So the first function for us is x plus 1 times x minus 1 divided by x minus 1. And the second one is x plus 1, right? Now some of you, well, all of us, what we'll do is we'll just try to cancel this out, right? So when we cancel this out, we are left with x plus 1 and we say, well, they are equal, right? So since we just cancel these out, they are equal, right? But actually speaking, they are not equal. Now, why are they not equal? This is what you need to answer. Now, one way you can answer this is that here, if you see or analyze this function, what kind of discontinuity does this function have? Can this function have value of 1? No, correct? So now here we know in this function, x is not equal to 1, right? Why it is so? Because if you put x equals to 1, you get something divided by 0. Therefore, the domain is restricted. So the domain of the function is x belongs to real numbers, where x is not equal to 1, correct? Here, do you have any restriction in domain? No. Right here, no restriction in domain. Do you understand? Now here x can have all the values, correct? X can be 1. If x is 1, the value is 2, right? So that is how it is. Even if you graph these functions, right? If I graph this function, for example, let me graph these functions and show you how they will look like. So let me just show you two graphs here, which should give you these two functions. Now, this function, which is x plus 1, will have y-intercepted 1 and slope of 1 also, right? So it will be a straight line like this, correct? Now there is no restriction here for x equals to minus. If I write x as minus 1, right, what do I get here? At x equals to minus 1, I get 0, right? Which is, in this particular case, x-intercept. Now here, can I write x equals to minus 1? Yeah, I can write. But how about x equals to plus 1? Now if I write x equals to plus 1, then what do I get? I get 0 here, right? Now in this case, at x equals to plus 1, I get 2, a value here, right? I meant plus 1. So you have a value there. In this case, if I write x equals to plus 1, then what happens? The denominator becomes 0, right? So therefore, we cannot have x equals to 1. It is not in the domain. So how will the graph be of this function? So graph of this function will be not like this, but it will have a hole at x equals to 1. This point, right? So the graph will be actually like this. Do you see that? That is the difference. At x equals to 1 and y value equals to 2, there will be a point in this function, correct? But in this function, there will be a hole, correct? Therefore, these are very different functions. Well, can you make them equivalent? Yes, you can. Yes, you can. How can you make them equivalent? Now that's the next question. How can you make them equivalent? That is the question. You can make them equivalent by restricting the domain, because that is the only difference, right? So here, if you write the other function, which is this one, as x plus 1, where x is not equal to 1, in that case, this becomes equal to x plus 1 times x minus 1 over x minus 1. Since here, the restriction is already there. X is not equal to 1. The restriction is there since x cannot be 1. Do you understand? So if you write this condition, then only they are equivalent. Therefore, remember one thing, that is, whenever you cancel out and write this as an equivalent algebraic function, in that case you should include this restriction. If you don't include this restriction, then they are no more equivalent. So your answer may not be correct at times. You may lose some marks on that also, correct? Now here, you understand exactly, with the help of a diagram, that the rational function has a hole, whereas this line does not have a hole. But if you write x equals to x not equal to 1, this will also have a hole, correct? In that case, that function will also be drawn in a similar fashion. It will be drawn like this with a hole here and then, correct? So this represents x plus 1, where x is not equal to 1. Do you understand? So at this point 1, we'll have a hole on this, correct? So now they're equivalent. Otherwise, they're not equivalent. This is a very important thing. I hope you appreciate it. Thank you.